Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be starting a new series that is the advanced Python lessons, and the first lesson is going to be Lambda functions. So if at any point you feel that you're enjoying the content of this video, please make sure to slap that like button, and I do implore you to give me a like because I need to beat the YouTube algorithm and whatever algorithm is out there. So without any further ado, let's go ahead and get started. Okay, so this is Lambda functions. We're going to be explaining what these are since these are a bit more advanced lessons. And again, to get started, I recommend that you go through the beginner lessons just to understand how things work, especially the functions part. I'm going to link the functions video somewhere at the top. So I do recommend that you go through them before you watch this one because it's slightly more advanced and there are things that you need to know. I will approach this as a complete beginner. I will take into consideration a complete beginner watching this video, but just in case, I do recommend that you watch that. Without any further ado, first of all, Lambda are small single expression functions that do not need to be named. And this is why Lambda are sometimes known as anonymous functions. So the keywords here are small, single expressions that don't need to be named, so you don't need to name them anything. That's why they are sometimes referred to as anonymous. And you'll see what I mean by single expression, or not me, I didn't create these, but what people mean by single expression and small. So let's look at the structure of a Lambda function so we can better understand what single and small mean. So this is the expression. So the Lambda's general form is the keyword Lambda. So if you know functions in Python, they start with def. This one, because it's Lambda, starts with the Lambda keyword followed by one argument or multiple arguments and then the expression. So the arguments are the parameters that you pass to the function. These can be 0, meaning that no arguments at all, or more. So you can send 1, 2, 3, 10, whatever you need. And then you have expression, which is a single expression which is executed and its value is returned by the function. Like the def, this expression creates a function to be called later, but it returns the function instead of assigning it to a name. So when you use a Lambda expression to create a function, it doesn't automatically assign the function to a name. Instead, the Lambda expression simply returns the function object itself. And yes, you heard me right, the function object, because in Python, functions are also considered to be objects. So when you call the Lambda function or the Lambda expression, the function object is returned, which you can then choose to assign to a variable, if you like, pass as an argument, which will be super useful, and this is the most used case, or use it in any other way that you want. And keep in mind, Lambda's body is a single expression, not a block of code. So you know in if statements we have blocks of code. When we work with a function that has a def, we have a block of code. So the single expression right here is not considered a block of code. This is not super necessary for you to know, but you know, sometimes maybe you're in a job interview, somebody asks you, is this a block of code? You're like, no. They're like, wow, amazing, you're hired, let's go. Anyway, and then you can thank me later and give me a portion of your income. No, I'm not the tax collector, I'm not the IRS. Anyways, Lambda is designed for coding simple functions and the def handles larger tasks. So because it is limited to an expression, a Lambda is less general than the def, so you can only squeeze so much logic into a Lambda body without using statements such as if and so on. Once you start working with more complex things, then it's better to move on to the def normal function that we know. So enough talk, now let's go ahead and move on and start creating and testing out our ideas. Okay, so as you can see in here, we've defined a function that is named func, and the def keyword is used to define functions in Python. Now you might be wondering, hey Michael, aren't we working with lambdas? Why the heck are we creating a normal function? Well, fellow grasshopper, what we're doing in here is we're creating a function. I'm going to then convert this into a lambda expression so that you see the difference and it just creates the correct connections in your brain. Anyway, this function takes in 3 parameters that are the x, y, and z. So when a function is called, you need to provide these 3 parameters that will be assigned to x, y, and z respectively. Now inside the function, the code block is a single line that is the return x plus y plus z, and this line describes what the function does, and it's very simple. It basically takes the 3 parameters, the x, y, and z that you've sent, adds them together, and returns the result using the return statement that should return the value back through the function. And finally, what we do is we call the function right here inside of a print statement using the f string. And if you don't know all of these, then again, maybe you're like, whoa, what's all of this? I'm just a beginner. I'm trying to write print hello world. Well, you have to go back and watch the previous videos. I'm going to link videos right here at the top. You can go watch those, come back to the more advanced series. So very simple, we send in 1, 2, 3. What we should get is 1 plus 2 plus 3, which is 3 plus 3, which is 6. So I hope my calculations are correct. And yes, indeed, we do get a plus 6 right here. So this is a normal function. Very simple, nothing too much in here. Now I'm going to convert it into a Lambda function so that you can see how it looks like. Okay, so as you can see in here, we've created the Lambda function. So first of all, what we have is, just as we talked about, we have the Lambda keyword that is used to create a small anonymous function in Python. And again, why is it anonymous? Well, because right here we've named it func. The function was named func. In here, we don't have a name for our function. So in here we have x, y, and z, the parameters that will be sent to our Lambda function. So this is the parameters that we need to provide it with. It's a bit different, but you can start seeing the similarities and how these things work. And we assign the Lambda function to a variable named the Lambda underscore func. So this is just to differentiate between the normal function and the Lambda function. So we store it in a variable, and then inside of the print function, the Lambda function is called with the arguments 1, 2, and 4. This is just to differentiate between the output. And now the output should be 1 plus 2, which is 3, plus 4, which is 7. Very nice. So, and by the way, again, we have the expression right here, which just adds up or sums up the x, y, and z. Sorry, this is the expression after the colon. So I do recommend that you go back. So let me just show you again right here. Boom, there we go. Lambda argument expression. This is how it basically works. So this is the expression. So when I right click and I run, boom, there we go. We have the output of 7. But you'll notice that we have a small warning in here over the variable name. So if I hover over it, it says E7 or PEP8 actually, PEP8 E731, do not assign a Lambda expression, use a def. So basically what's happening in here is that Python found that using the Lambda function isn't really beneficial to us in this case, so it's better to just create the def function. And in this case, it is true, using a Lambda function makes our code less readable in this situation and harder to debug. And on top of that, we cannot expand on it if we really wanted to in the future. So now let's move on and look at how we can make a better, more effective use of our Lambda functions. Okay, so in here Lambda functions are particularly useful when used with higher order functions, which take other functions as arguments. So a higher order function, such as the map right here, takes another function as an argument, and this is where Lambda really shines. So the first function we're going to be looking at is the map, and we're going to be looking at other ones as well. Let's go ahead and break this one down. First of all, in here we have the numbers list that contains 3, 5, 6, 12, 42, and 88. These are our integers. If you don't know how lists work, again, you're a beginner, you need to watch lists video that I will link somewhere at the top, or I've already linked it. Next, we have this line right here. I'm going to start breaking it down line by line. which is the map. And this is a built-in Python function. It applies a specified function to each item of an iterable, and iterables are like lists, and returns a map object. And let's say you're starting right here and you don't have an instructor and you're like, wait, how the heck does map work? If we hover over it, we get the documentation and you can see that it takes in the self, and we know that this is a constructor, so the self would refer to the actual object. And then the second parameter is a function, and the third one is an iterable. So we provided with a function that we want to apply to each object in an iterable. So right here, make an iterator that computes the function using arguments from each of the iterable and stops when the shortest iterable is exhausted. So basically, we use this as a function and we apply it to every single object inside of our iterable, which in this case is the numbers list. So what should be happening in here? The Lambda function that we created should take every element that is x from the numbers and square it to the power of 2. So this will be our Lambda function, and it takes in as an input the x and returns x squared. Now you might be thinking, how does x associate with each part of the number? Well, that is done using the map right here. So this part applies the Lambda function to each element in the numbers list, effectively squaring it. And finally, because remember what we said, if I hover over map, it returns the map object. So because it's a map object, if we try to print it out without the list, then it would just look very weird. So we have to convert it to a list using the list function. And again, this is necessary because the map returns a map object. And of course, we assign it to the variable squared and we print out the output. So again, this might be confusing. I know that because I've struggled with Lambda for a couple of months when I was also getting started with the... Actually, when I started with Python, Lambda wasn't available, but when it's got available to everyone and it was updated through Python, I was like, okay, this is kind of weird. Like, how does it know that the X is associated with individual items inside of this list? How does it know it? Well, this is how Lambdas work, because they are special functions that work in unison with these higher order functions. So when you have map, when you have numbers, each item from the number, so 3 is taken out, sent as x, and then x is multiplied by itself, or taken to the power of 2, or squared. Anyways, whatever it does, it's squared, and then it's converted. All of the items are done, and once you have the map object, it's then converted to a list and it's printed out. So when I right click and I run, boom, we get this output. So you can see 3 squared is 9, 5 squared is 25, 6 squared is 36, so on and so forth. But just in case you're not entirely sure how this works, what I'm going to do is I'm going to convert this into a normal function and you can see the difference. Okay, so in here what I did is I created a new function that is the square numbers. It takes in x as a parameter and simply returns x to the power of 2. This is how it would look like. So I commented this line out, I duplicated it. I should have duplicated before I commented it out. And then I'm going to, instead of the lambda, simply have these square numbers. But the trick part in here is that you should not have these parentheses. Why? Now, this is very crucial. When you're calling a function, okay, when you call a function, you have to provide it with the parentheses. Like, for example, right here. So right here, we're calling a function, so we're providing, but in here, we're not actually calling the function. We're simply using it as a parameter in the map. So it's not being called. So when it's not called, you shouldn't add the parentheses and provide it with x, because right now, x is unknown. It's not, so Lambda works in a special way with the higher functions. But when you're not calling it, you're simply telling the map, the higher order function, you're simply telling it that now use every single item in the numbers iterable, use the square numbers function on each individual item. So when I right click and I run, this is the output that I get. You can see that it's the exact same output, but instead of doing it in a single line, we had to do it in 3 lines. So 1 line using the lambda, 3 lines using the normal function. So it adds 2 more lines, it makes it less readable and less convenient. So in this situation, using the lambda function was a plus to us indeed. Okay, so again, we have a list of numbers in here that contain the following numbers. I'm not going to say them again. These are integers. Next, we have the filter. Whoa, there we go. Another built-in function that uses as its parameter. If we hover over it, let's just see what happens. So basically it returns a filter object. It's very similar to the map and returns an iterator yielding those items of iterable for which function item is true. Very nice. And if function is none, it returns the item that are true. So basically it creates an iterator from the elements of an iterable for which the function returns true. So basically it checks right here using this function. If this is used on the numbers and it returns true, then it adds this to the filter object. And then finally, after we've gone through all of these elements, we convert them into a list. So basically, this is our lambda function, and this lambda function checks if a given number x is greater than 10. Next, the filter part applies the lambda function to each element in the numbers list to test out the condition x greater than 10, and then the list converts the filter object. So if I right click and I run, boom, there we go. We get that we have only 15, 20, and 25 greater than 10. And keep in mind, this is strictly greater than 10, so 10 is not greater than 10. That's why the condition goes to false, and that's why it's not added to the filter object. I hope this makes sense. I'm 100% sure some of you are very confused because not only are we looking at lambda functions, but we're also looking at these higher level functions, which are the map and the filter. But please take your time, take a deep breath. If you have any questions, leave them in the comments below. I always answer within 12 to 24 hours. Take advantage of this because I don't have many subscribers. I wish I had more. Subscribe to the channel as well if you're here. So basically this is how the lambda works. It works with higher level, and again, if you want to test things out, I do recommend that you create a function that would do this test and returns a true. So that would be nice for you to get this more ingrained in your head. But anyways, let's move on and see an even better use of lambda functions. Okay, so as you can see in here, we have the students right here. That is a list containing tuples, where each tuple represents a student. And the first element of each tuple is a string, that is the student name. And then the second element is an integer, that is the student's score or grade or whatever you want to call it. So list, square brackets on each side makes it a list. And what is it a list of? It's a list of tuples. Why are these tuples? Because they are surrounded with round brackets instead of square brackets. So you can see, wait, this is very cool actually. If I hover over this, you can see list, tuple, string, integer. Boom. This pie chart is amazing. That's why I highly recommend that you use this as your IDE to learn Python and work in Python in general. Okay? So should be clear, already covered this, and notice that the comma inside of the tuple divides or it creates the separation between the string and the integer, and then the comma on the outside between each item, between each tuple. Next, we have this line right here that uses the built-in function that is the sorted function that will sort out our students list. And in this case, the sorting is done based on a specific criteria. Now, usually we would, if we just use sorted, it would sort it out either if they are integers, it would sort it out from the smallest integer to the biggest. If we're using strings, it would sort it out using the first string right here. So for example, A would be behind Bob, but our goal in here is to sort it using their numbers, and it's hard to get to these scores. It's not really easy. That's why we use the key parameter right here, and it's used with various functions that require sorting or ordering. So when you provide a function to the key parameter, that function is applied to each item in the iterable, and this is the iterable. The students, we've already talked about it, and the results are then used for the sorting or comparison process rather than the original items themselves. So if we just leave it right here just for students, let's say without the key, what will happen is each tuple will be compared with the other tuple. I don't even know what the output would be. Like, what could it be? So as you can see, like basically nothing happens. Did anything change? No, I don't think so, because let's try to just switch Bob and Alice. I just want to see. I honestly don't know what will happen. Will they stay the same? Oh, so as you can see, what it did is it accessed the string and compared it based on the strings themselves. But we don't want that. We actually want it to be compared using the student's integer. So the way that we do this is using the lambda function. So this line right here, so after the key, defines a lambda function that takes in a single argument, that is the student, which is a tuple, and returns the second element inside of that tuple. So we return that second element using the square brackets, which is the student score, and this score is used as the key for the sorting. So, and finally we have the sorted function right here that sorts out the items in an iterable in ascending order by default and based on the returned key from the lambda function. So the students right here should be organized by their grade. And I hope this makes sense. If you want, I can go through it again. I'm talking as if I'm teaching a private class, but anyways, again, using the lambda keyword, we create or we instantiate, and we start by defining the anonymous function that is the lambda. It takes in a parameter that is a student, and that means student is going to be a tuple, because remember, it takes in individual items from the list. So this will be student, this will be student, this will be student, and then we access the first element. Remember, the elements start at 0, so Charlie would be at 0, 92 would be at 1, 0, 1, 0, 1. So at 1, we return the score or the grade or whatever, and then that will be our key. So now when I right click and I run, look at that. How cool is that? So now Bob, because he has the lowest grade, is the first one. Then we have David, Alice, and Charlie, and they are now represented or ordered by their grades. Whew. Fellow Python programmers, that was confusing. I know. These are kind of advanced stuff. And again, you have to know that I've called the series Advanced Python, so you should be in the know that these are things that are not that easy. We've looked at map, we've looked at filter. Sorted is something that you've seen before, but you might have not worked with the key parameter before, so that might be new to you. And I promise you, I understand you're not alone. When I saw how the lambda function works, like how does it know that the student is part of the students? Confusing, I know, but slowly you get used to it and you see how convenient and how helpful it makes your code. How helpful it makes your coding journey. And when somebody sees you using Lambda, they know that you're serious, they know that you've gone through a lot of steps in Python, and they're more confident in giving you side jobs or just hiring you. So knowing these stuff is very important for you personally as a coder. It helps you transform your mind into a coder better. And just knowing it is very nice. Now, you've already seen this. Any questions? Leave them in the comments. Am I glaring? I'm too white in this. Anyway, then once you've properly understood this, asked all the questions that you have, it's time for a bit of a challenge to test out your knowledge. Okay, so Lambda real-world applications. Let's go ahead and look at this. So a lot of information is going to be in the description or the pinned comment. So if you are having a hard time finding any of these resources, or maybe I've missed any of the resources, please make sure to let me know. First of all, you'll need to print out the people in the dictionary. Whoa, we're working with dictionaries now. Provided in the description in order of their age. Now, dictionaries, crazy. You'll have to try your best at doing that. Next, you'll need to print out the people in the dictionary from the tallest to the shortest. This is going to be a bit of a trick in here that you'll need to find, but if you can do the first one, I think the second one is manageable. Again, remember, read the sorted documentation to find what you need. Next, you'll need to create a class of vehicle that has a constructor that takes in 3 parameters, model, year, and mileage, and define the __str__ special method. If you don't know how classes work, I'm going to link a video somewhere at the top. Create a list of 3 vehicle objects. So you just simple list that contains 3 vehicle objects using the information I provided you in the description or the comments. Print out the car with the highest mileage using the max method. So again, you'll need to do a bit of research to find the max, how the key works in a max. Does it have a key? Like, how does it work? How can you max or find the max using specific elements? That's going to be for you. And also don't forget, like, you'll have to use, and don't forget you'll have to use the Lambda with the key, with the max, all of that stuff. Print out the oldest car using the min method. Now, define a new method that is age_penalty in the class that returns the current year subtracted by the vehicle's year multiplied by 1000. Okay, sounds crazy, but you have to do it. And then find the vehicle with the highest effective mileage, which is the mileage adjusted by the age penalty. So sometimes what happens when you're working with a car, and maybe you don't know this about cars, I don't know this either, I just found it in the exercise, I had to do some research. But basically what happens is sometimes a car is very new, but it has more mileage on it. So that way the car shouldn't be more expensive, it might be less expensive. But how do you calculate that? Like, if the car is very new but has more mileage, is it better than an old car with less mileage? These are calculations that I don't know, but basically what happens is there's something called the effective mileage, which is added with the adjusted by the age penalty. So you'll need to again find the vehicle with the highest. Highest means what? When we talk about highest, means max. So you'll need to apply the age penalty function inside of the class to each of the items to find the car with the highest effective mileage. Crazy. Don't worry, do these step by step, slowly, don't feel overwhelmed, do your best, pause the video right now and go do the challenge. Okay, so as you can see in here, what I did is I just separated the explanation code, simple code, from the challenge with these funky lines. I don't know why I spent so much time on that. But anyways, right here we have, or we've initialized a list of people which has elements inside that are individual dictionaries. And each dictionary will represent a person with the keys name, age, and height. So name, age, and height, we have 3 dictionaries for 3 different people. Next, we have this line right here that is going to sort out these people using the sorted function. And this sorting is going to be based on a specific criteria, again, just like we've talked before. And that criteria is going to be the age. So this is going to be very similar to what we've done before, but this time instead of using the index like we've done right here, so in here we got every element from the list, assigned it to student, and then accessed the first element. In this case, we have person. Why is person? Shadow name from outscope. I think this is the problem. Person. I don't know. Anyway, keep it. It's not going to cause any issues. So right here, basically, what's going to happen is we're going to access every individual element from the people's list and store it in the person variable, and then access the key with age. And if you don't know how we're accessing this using the key name of a dictionary, then trust me, you have to watch a dictionaries video that I'm going to link at the top. But anyway, we're accessing the age of each person, we're using it as a key and then sorting it out, and then just using a for loop to print out every single person. So click, run, and whoops, there we go. So these are going to be the challenges. And as you can see, so right here we have, okay, so it's by age. So 25, 30, and 35, even though B should come after A, but we are sorting them by their age. Very, very nice. Let's continue on. Okay, so as you can see, first thing I did is I renamed this to underscore age because we're going to be sorting people as well in here, but this time by their height. And the only thing, or the one thing I changed was instead of accessing the value at the key age, now I access the value at key height and provide it as the key to the sorted function. But remember, I told you we want this from the tallest to the shortest. And if we just do this like this, for example, without the reversed, right click and run. And as you can see, okay, this needs a bit of separation in here. Boom, okay, there we go. So as you can see, we go from shortest to tallest, but we wanted the reverse. We wanted the tallest to shortest. So in here, you can provide this with reverse equals true. And if you're struggling with that, I gave you a small hint that if you hover over the sorted, you can find right here reverse and bool, and you can read more about it in the documentation to find how to use this reverse. But basically, just provide the reverse with a true, which means it will reverse it. So now we should see Bob at the top because he is the tallest. Boom, there we go. Bob, Charlie, and then finally Alice. So pretty simple. I don't think there's too much in here. If you've understood this one should be pretty easy, except for the reverse in here that might have taken you off guard. Anyway, let's continue on. Alright, so as you can see in here, we've defined this simple class, and we start off with the class syntax in here, or class expression, whatever. Now inside we have the init method. That is a special method in Python classes, and it's called whenever a vehicle object will be created. This init is called a constructor. So it takes in 4 parameters: the self, the model, the year, and the mileage. And I'm not going to delve too deep, but basically the self, because I've covered this, and I'm going to link the object-oriented, the OP, the classes video somewhere at the top. But basically the self refers to the instance of the class. The model, year, and mileage are just going to be arguments sent to it so that we can fill in these attributes that have the same name as the parameters. And then we have the special method, that is the __str, that just returns, which is also another special method like the init, and it just represents the vehicle in a very nice string right here, instead of just printing out a ugly looking vehicle object. Now let's continue on and let's create the vehicles list. Hey, that was fast. So I just copy and pasted it because I don't have time to write every single one. It's not necessary. So basically this is going to be the list of vehicles that stores instances of the vehicle class, and each instance is created by calling the vehicle right here, as you can see. And when we do this, the init constructor is called, and we provide the model, year, and mileage. And if you're thinking, whoa, where's the self? Didn't we say that 4 parameters? Well, if you don't know your classes, then you should know that this vehicle is the self in itself. So this is how basically it works. Let's go ahead and continue on. Okay, so ladies and gentlemen, I just had a little bit of a brain fart right here. So basically what happened is I just remembered that when I was telling you about the challenge, so right here I remember that I explained the max and how this works, and then I said the same for this point right here. It's not the same, because in this one we had to find the car with the highest mileage, and in this one we had to find the oldest car by its year. So basically in here, this is what we are doing. And the reason for this part of the challenge is for you to understand how you can use Lambda to access attributes of certain objects, and how effective, like Lambda, you can access items inside of tuples. We've seen how you can also use it on dictionaries, and now we're using it on objects that we've created. So we're really taking this Lambda thing to its extremes. But anyways, what's happening in here is, let's start with this one right here at the top. So this function is going to be used to find the vehicle with the highest mileage in the vehicle list. First of all, we have the vehicles right here. That is the list with the vehicle instances. Next, we have the key equals lambda vehicle, and then the expression is going to be vehicle.mileage. So this specifies a Lambda function that takes in a vehicle object as an argument and returns the mileage attribute of that vehicle. So this is going to be an instance of the vehicle object, and then we access the attributes using, or the attribute mileage, using the dot product. And then finally the max, and by the way I said dot product, this is the dot product. It's just the dot that allows us to access the attribute. And then we have this max right here. This max function uses this key to compare the vehicles and determine which one has the highest mileage. So just like we've used the key right here, just like we've used the key right here, this time we're doing the same by accessing the mileage. And finally, right here we print out the vehicle, because this max will return the instance vehicle, and then it's stored in the max mileage vehicle and it's printed out. Before I right click and run, let me explain this to you, but this should be pretty simple because it's doing something that's very similar to the max, but this time it's finding the vehicle with the earliest or smallest year, which translates to the oldest vehicle in the list. So similar to how the max works, where we provided the key and then we said for each vehicle instance we're accessing the mileage, this time for each vehicle instance we're accessing the year, but we're finding the minimum, and then we print out the vehicle. And the vehicle, I don't even know if I'm writing the word vehicle correctly. So guys, don't judge me for that. I just had a massive brain fart as I was writing this line of code, because you know, when you remember something that you've done before and then it was incorrect and you're like, okay, I need to go back, did I say that? And during that process you just start making mistakes. Anyway, let's continue on. So when I right click and I run, as you can see, the vehicle with the highest mileage is SUV. So let's see, is it that true? And by the way, if you're like, oh, how do I understand these numbers? You can actually add underscores every 3 right here. So it makes more sense. Right click and run. You can see no errors at all. And what do we get in here with 15,000 miles? Let's see, 150,000 miles. Yes, indeed, it's the SUV, which is made in 2018, and the oldest vehicle is the sedan, and boom, there we go. It did find it indeed. Very, very nice. Let's continue on. Oh. Alright, so first of all, what we did in here is we created this method, and this is a method, not a function, because even though it looks like a function, it's inside of our class vehicle, so it's called a method. You should know that if you've watched the videos that I recommended for beginner students. This method calculates a penalty based on the age of the vehicle. So this concept is to add a cost or a penalty for older cars which might be more worn out even though they might have less mileage. So that's very important. First of all, we set the current year at 2024. You might be watching this in 2079. I doubt there will be any YouTube if we're all still alive, if the nuclear fallout hasn't killed every single human on this planet. Maybe cockroaches are watching this video. Sets the current year. And usually in a real application, if we were like taking this very seriously, this would be dynamically obtained using the datetime library. But because our focus is on using Lambda functions, we're going to just assign it this value of 2024. Next, we have the return right here, and this calculates the age of the vehicle by subtracting the vehicle's year, subtracting the vehicle's year, that is the self.year, from the current year, and this difference is then multiplied by 1000 to represent a penalty in terms of the mileage. So this means that for each year the older the vehicle is, what did I just say? So each year that the vehicle is older, it has an additional 1000 miles of wear and tear, because even if you store a vehicle somewhere in your garage or whatever, over the years it accumulates more hidden miles, if you want to call it that. You don't see that. I said hidden. So it accumulates hidden miles of wear and tear. I don't know, I'm so tired, I'm so hungry. Next, if we scroll down right here, so the most used vehicle, we are using the max again. So this line right here will determine which vehicle has the highest effective mileage. And right here, this is the most interesting part, because we know how the key works, we know how we've defined the entire Lambda. Now what are we doing in here? Basically, we're getting the vehicle, we're applying the mileage attribute, so we're getting the mileage, and then we're adding the penalty to it to see which one has the most effective one. So are you ready? Let's right click and run, and we can see that the vehicle with the highest effective mileage, it's still the SUV at 150,000 miles. Congratulations. So this is Lambda functions. Ladies and gentlemen, congratulations on making it to the end of this video. I'm really tired. I need to drink some water. I mean, maybe you're overwhelmed with this because we have covered a lot in here. First of all, Lambda functions seem scary until you start working with them time after time, and they just become second nature to you, just like anything when it comes to Python programming. So I implore you, if you went through this video and you're still not sure, I do recommend that you go through every single example. If you have any questions, leave them in the comments. And once you're really good, if you properly understood how the Lambda works, do the challenge again and again and again until you get every single point correctly. Now, also on top of the Lambda functions, we've looked at the higher order functions like the map, the filter, the sorted, which use other functions as their parameters. And you might be thinking like, that's too much information, but there's no other way of learning Lambda functions, because that is the effective way of using them. There's no other way. So like again, the title of this video is Advanced Python Lesson, so you should have been aware of what's happening. I've left a lot of things. If you need like more information of the basics, I'm going to leave the links in the video. I was too far from my microphone. I just realized that I was leaning back. Oh, finally. In any case, in the next video, we're going to be continuing on our Advanced Python lessons, so you should watch list comprehension, I think. List comprehension. Continue your Python programming journey. Congrats if you've understood what's happening. You are like advanced Python. Wow. Thank you for being on this journey with me.